Okay, Algebra 2, picking up where we left off, finishing up this review. Okay, composition of functions. So we have function f of x and g of x, and we want to figure out f of g of -2. So remember that means we're going to start with figuring out what g of -2 is, which means we're going to plug -2 into the g rule in place of the x. So g of -2, so 5 times -2 plus 9. That's -10 plus 9, which is -1. So now this becomes f of, I'm putting this -1 here in place of this, f of -1, which now means I'm going to plug -1 into my f rule in place of x. So this is going to be f of -1 is 2 times -1 cubed minus 1. Notice I'm putting the -1 in parentheses and cubing it. Right, that's how you also need to enter it into your calculator. So that's 2 times -1 minus 1. So then that's -2 minus 1, which is -3. So f of g of -2 equals -3. So the idea of composition is you take your answer from the first part and then put it into the other function. This one's going the other way. We're going to start by figuring out what f of 4 is. So that means I'm going to put the 4 into rule f in place of the x. So I'm going to have 2 times 4 to the third minus 1. Okay, order of operations, I power before I multiply. That was the same thing here. I did not multiply the -2, the 2 times the -1 and get -2 and then cube it. Order of operations, we power first. So that's 2 times 64. Remember, 4 to the third means 4 times 4 times 4, and then minus 1. So that's 128 minus 1, which is 127. So that's f of 4, but I want g of f of 4. So I need g of 127. So now I'm going to take 127 and put that into rule g in place of the x. So 5 times 127, and then add the 9, you should be getting 644. So g of f of 4, right? So when you start by putting 4 into f and then that answer into g was 644. All right, simplifying rational expressions. So we're going to simplify, and then once we have, or not simplify, but we're going to factor, and then once we have everything factored, then we can cancel out those giant ones from the top and the bottom. Remember, I can't cancel like these x squareds right now because of the adding and the subtracting. And when we factor, we always are looking for, is there a greatest common factor? Do I have difference of squares? And then usually it's like, okay, let's box and diamond. So looking at this, I do have a common factor of 2x. These both, 2 goes into both of these and x. So this is 2x times, and then I'm thinking 2x times what is 2x to the second? That's an x. 2x times what is 4x? That's 2. On the bottom here, this is difference of squares. X is a perfect square and 4 is a perfect square. This is like having x, the other. This is like having x to the second minus 2 to the second. So when I'm comparing it to this is my a, this is my b. So that factors into x plus 2 times x minus 2. This bottom here, I'm just going to write it in expanded form. And this 4x squared plus 13x plus 3, box and diamond. So here's 4x squared, here's 3. The diagonals have to multiply to be the same, so they have to multiply to be whatever 4x squared times 3x is, which is 12x squared, and has to add to be in my middle, which is 13x. It's going to be 12x and 1x. Here's 12x, here's 1x. You could have them flip-flopped. The common factor here is a 4x. Remember, this would be an x, this would be a plus 3, this would be a plus 1. So here I have x plus 3 times 4x plus 2. All right, and I'm going to look for those pairs on the top and bottom. So here's one. Let's see what else we have. I got this x plus 3 and this x plus 3. And just make sure I'm not screwing anything up here, right? That's all I'm seeing. Those are my only pairs. So what am I left with on top? I'm left with a 2x times a 4x plus 1. And then on the bottom, I have an x plus 2 times an x plus 3. Remember, when we do these problems, we also talk about the excluded values. Those are the things that can't be included because they would make our bottom 0. So from From the beginning here, what would make our bottom 0? -2, 2, -3. Right, so my excluded values are 2, -2, and -3. All right, so moving on to this next one, same idea, except for division, which means I'm going to have to flip the second one. Here, I'm noticing that's another difference of squares. That's like having x to the second minus 8 to the second. So then that's going to be x plus 8 times x minus 8. Okay, so that's what I have up here on top. On the bottom, I notice I have a common factor between these of 2. So I'm going to pull the 2 out. It's like undistributed. 2 times what is 2x? X. 2 times what is 16? 8. And here I'm going to flip-flop these. So I'm going to just put the 4x squared on top. Sometimes it helps to like think of that as 4 times x. Like sometimes an x can cancel. You don't have to do that. You could leave it 4x squared. And then when I look at this, I notice I have a common factor of, let's see, an x, right? They all have an x. So I'm going to have an x in front. And I think up here, I'm just going to write, what would I have left? If I pull an x out, I would have x, or 2x squared. Sorry, I forgot that 2. 2x squared plus 19x plus 24. So I want to make a box and a diamond over here for the 2x squared plus 19x plus 24. So they have to multiply to have the same denominator. So this would be an annoying 96 x squared, and it has to add to be 19x. So we're going to play around with some factors of 96 to see what we need to get to 19. So when I look at that 96, I don't know, does 4 go in there? 4 goes into there 24 times. That's not going to help me get to a 19. Let's see what else. Does a 6 go in there? 6 goes in there 16 times. That does not help me. How about an 8? Put an 8 in there. That gives me 20. Oh my gosh. What's the matter with me today? This is a 24, not a 48. Oh my gosh. I'm like sitting here freaking out. They're never going to let me make a video again. So let's do this again. Well, at least we'll be able to get an answer now. This should be a 24, which make this a 48. All right. 48 divided by 3 is 16. There we go. 48 divided by 3 is 16. So this is 3x and 16x. Oh, 3x and 16x. From here, I can pull an x, and here would be a 2x, x times 3, 2 times 8, and then 3 times 8 is 24. Oh boy, 2x plus 3, and then x plus 8. All right, so now let's look for some pairs to get rid of. This and this are gone. And what else? This x and this x are gone. And this x plus 8 and this plus x plus 8 are gone. And then the last thing, right, I've got a 2 and a 4. 2 goes into 2 once and 2 goes into 4 twice. So on top, I'm left with that 2 and this x. On the bottom, I'm left with a 2x plus 3. All right, and then excluded values, we go back to here. What would make the bottom 0? So 8 would make the bottom 0 here. 0 would make the bottom 0. -3/2 right here. And -8. Those are my excluded values. All right, last one. So factoring, there's no GCF. It's not difference of squares. I'm going to try to not screw up this box and diamond. Okay, so it has to multiply to be this, which is -60x squared, and add to be the middle, -11x. It's going to be -15x and 4x. In common between these, have a 3 and an x. So this is a 4x. It's a -5, and that's a +1. So this top is 3x plus 1 times 4x minus 5. On the bottom, they do have in common a 2 and an x, so I'm left with 4x minus 5. That 12x to the third, it might help again to sort of break it down. And then 9x to the second, that's difference of squares. It's like having 3x squared minus 1 squared. So that's 3x plus 1 times 3x minus 1. So 3x plus 1, 3x. Ugh, too many symbols there. Happen. 3x minus 1. All right, let's see what we can get rid of. I can get rid of a 3x plus 1. I can get rid of a 4x minus 5. I can get rid of an x. I can divide the 2 into the 12 is 6. And so on top, I'm left with 6 times x, so that's 6x squared. On the bottom, I'm left with 3x minus 1. Excluded values. What would make this bottom equal 0? So 0, right? 2 times 0 is 0. Here, if I set this equal to 0, that's 5/4. Here, if I set that equal to 0, it's negative 1/3. And if I set this equal to 0, it's 1. So those are my excluded values. All right, and then last thing, logarithms, expanding and condensing. So we're going to use those log properties, right? So log base b of m plus log base b of n equals the log of the product, right? Log base b of m minus log base b of n equals the quotient. And a log base b of m to the n equals n times the log base b of m. All right, so I'm condensing. That means making as small as possible. But to be able to use either of these properties here, the sum and the difference ones for the product and the quotient, notice there's nothing in front of the logs. So when I see this 3 times the log of z, I cannot condense anything until that's gone. So I have to start with this property here, right? The 3 is like my n. I have to bring that up as an exponent. So I have the log of x plus the log of y. I'm going to pause for a second.
This is just a friendly reminder to our staff that there is a meet and greet for our new assistant principal happening right now in the library. If you can, go say hello and introduce yourself. Thank you. Bye-bye.
Okay, so I brought the 3 up as a power, and now these are all being added, so I can rewrite it as a single product. So x times y times z to the third, right? Condensing the log of a single expression, nothing in front of the log, just one thing. Okay, so here I'm going to have to start the same way. I can't use I see the difference. It makes me want to do this, but I can't do that when there's stuff in front of the logs. So this 5 has to come up, this 2 has to come up. So I have log base 3 of a to the 5th minus log base 3 of b to the 2nd. Now I can rewrite it as a single log base 3 of a to the 5th over b to the 2nd. Right now I'm going from this form to this form. Some people will put log divided by log. It's just one log over here, so watch that. All right, so now this one we're combining adding and subtracting. So we're going to use order of operations. We add first, right? So that means we're going to combine this into a single product. So p times q minus log base 2 of r. And now this is subtraction, so I can rewrite it as a quotient. So it would look like that. All right, so that's condensing. Expanding, we're now going the other direction. So I'm trying to make it as big as possible. So the first thing I see is this division. Well, division can be rewritten as subtraction. So it would just look like that. Okay, this is 2 things being multiplied. Okay, the powers aren't on the outside. I cannot bring the 2 or 3 in front right now. It's 2 things being multiplied. So I'm going to rewrite it using addition. Now I can bring those powers in front. Okay, and you do, if you're expanding, you do need to bring the powers in front. Like you have to get kind of as long as you could possibly have it be. Okay, so then that would be expanded. All right, and then this last one, kind of the same, kind of putting these 2 together. So first I see the subtraction. So I'm first going to split it into the a squared, the log base 5 of a squared times b cubed minus the log base 5 of c But then this is two things being subtracted, so then I can split that into two things being added. And then one last thing, and these have powers on them, the powers come down in front. Again, we want it to be as long as we can make it using all of the properties. All right, and like I usually put parentheses around these that they're called the argument. If you don't have the parentheses, that is also okay. All right, should have mentioned that maybe earlier. All right, a lot of times I will put mine in parentheses. If you don't have the parentheses, it is still okay. All right, well, I hope that all helps. Sorry for all the mistakes this time.